Hello students. Now let us discuss about the subject discrete mathematical structure, and we are concentrating on model question papers and its a solution. Let us look into the first problem. The first problem it is show that the compound proposition P biconditional to Q conjunction with Q biconditional to R conjunction with R biconditional to P. This is logically equivalent to P conditional to Q conjunction Q conditional to R conjunction R conditional to P. For primitive statements P, Q, R is logically equivalent. See, if there are three primitive statements P, Q and R, then we have to consider the truth values 8 numbers. Okay, so truth values will be considered 8 numbers, and this entire compound propositions will be split into small propositions, so where the table can be taken appropriately. So look at the table here. The first primitive, the first proposition P, we have defined the eighth truth values as 4 times zeros, 4 times 1. And the second proposition Q, 2 times zeros, 2 times ones and repeated. And the third proposition 0, 1 alternatingly. Okay. So now let us take the first proposition P conditional to Q. So P conditional to Q means if I have 1 conditional to 0, then this value will be considered as 0. Otherwise, all the values will be taken as 1 itself. So look at here, 0 conditional to 0, it is 1. 0 conditional to 0, again 1. 0 conditional to 1, again 1 it is. So like that, now if you observe 1 conditional to 0, that value is 0. So which is conditional law. Okay. So likewise 1 conditional to 1, it is 1 conditional to 0, it is 0, and rest all the values will be 1. So same thing applicable for Q conditional to R. So this time you have to look the table of Q, R. So 0 conditional to 0, 1. 0 conditional to 1 is again 1. 1 conditional to 0 is 0. Next, 1 conditional to 1 is 1. 0 conditional to 0 is 1. 0 conditional to 1 is also 1. 1 conditional to 0 is 0. Next, 1 conditional to 1 is 1. Similarly, we have to find for R conditional to P. R conditional to P, the same similar conditional application you have to apply. And the next, we are supposed to choose the compound proposition this entirely. P conditional to R, conjunction with Q conditional to R, conjunction with R conditional to P. So conjunction means if I have one conjunction to 1, then its truth value will be 1. If not, for all the possibilities, the value will be 0 only. For all other possibilities, the value will be 0 itself. Okay. So look at here, the same thing has happened. One conjunction is 1. Rest all the values we got it as 0. Finally 1, because all the three values are conjunctions. One conjunction, 1. Next, for biconditional, 0 biconditional to 0 and 1 biconditional to 1. Only for 0 biconditional to 0 and 1 biconditional to 1, we have the truth values as 1. Rest all the values will be 0. This you have to remember. So look at here, P biconditional to Q. So 0 biconditional 0 is 1, 0 biconditional 0 is 1. Rest all the values is 0. Lastly, 1 biconditional and 1 biconditional values is 1. So similarly, we have done for Q biconditional to R and R biconditional to P. Then for all the three propositions, we have taken one more compound proposition, that is conjunction. So conjunction we already defined. One conjunction one is 1, rest all will be 0. So that is what the last table we got. And if you observe this table and this table, the truth values are one and the same, which says these two compound propositions are logically equivalent. These two compound propositions are logically equivalent. Hence the problem.